Hello and welcome. In this video, I'll explain how to divide a polynomial by a binomial of the form ax minus b. If you're watching this video, I hope that you've taken the time to watch the lesson where I explain how to use synthetic division in dividing polynomials by a divisor of the form x minus b. As the process of division by ax minus b, so the coefficient of x here is different than 1 compared to coefficient being 1 in here, will be exactly the same, but division by ax minus b will hold a little bit of a surprise at the end, which we'll discuss together. I also hope that you have taken the time to practice an example. Whenever you learn something new, practice it right away, because understanding something is step one to learning. In order to internalize learning or make it your own, you must practice the skill that you just understood or you just saw or learned to make it your own. So let's not waste more time and let's get started. So when we are dividing by a divisor of the form ax minus b, remember synthetic division is applicable in here because divisor is in linear form. The first thing we want to do is list the terms from highest to lowest degree, and it seems that we have a little bit of work to do here because the terms are not listed in correct form. So the first term must be the third degree term, which is the highest degree we see there, 6x cubed. Then the next term, negative 19x squared, and then we have plus 18x, and then minus 20. And that will be divided by 2x minus 5. Remember that the divisor must also be the terms must be listed from highest to lowest degree. So the next thing we want to do is identify the coefficients. Now this is our divisor, ax minus b, okay, or 2x minus 5 in our case. And we must identify the coefficients in the polynomial we are dividing, or we call this the dividend. And we'll list them all. 6, negative 19, positive 18, negative 20. And as always, I will space them out a little bit and draw the half rectangle to organize my work. The next thing we want to do is figure out what number to put in here. Remember that in the previous example, we said that we just have to place the value of b in here, right? And you can discover the value of b by just following the pattern, comparing x minus b with the divisor you're given, and you can easily identify b. But another way of looking at it is finding the value of x that makes the divisor 0. So x minus 3 equals 0 at x equals 3, so your b value is there. And this method in here will become handy now that we have a divisor where the coefficient a is different than 1. So we're going to say that 2x minus 5 equals 0 at x equals 5 over 2. So 5 over 2 will go right here. Oopsie. Don't know what's going on here. Let me see. Okay, so let's get started with the method. As I said, exact same thing we did in the previous division by x minus b, right? Bring 6 down. Multiply 6 by 5 over 2. That would equal 6 over 2, 3 times 5, 15. And negative 19 plus 15. We must list them below each other, right? Negative 19 plus 15 is negative 4. Keep going. This time multiply negative 4 by 5 over 2. Negative 4 times 5 over 2 is negative 10. So add positive 18 to negative 10, and we get positive 8. Next thing, we multiply 8 by 5 over 2. Actually, let's keep it consistent. Make it green here. And that will give 20. Add negative 20 to positive 20, and you get 0. And now we think, okay, so we think we're almost done. It seems that we already obtained the quotient, the coefficients of the quotient, 6, -4, and +8. So I would say that all I have to do is stick the variables. So the first term must be an x squared term. Remember that we're dividing third by first degree. So second degree would be the first degree term, and then the constant term. So we must say, hey, we're done. Qx equals 6x squared minus 4x plus 8. So we finish the division, remainder is 0. But we'll stop for a second and think, you know what, why don't we perform long division to check and see if we get the same answer? And you know, in math, doesn't matter what method we use, we should get the same method regardless. So we're going to do the the long division this time. So here we go, 6x cubed. We can do this a bit faster, right? Because we have practiced this a little bit more by now. Divided by 2x minus 5. Nice straight line here. Here we go. So remember that we compare the first term in the divisor by the first term in the polynomial. And we have 2x minus 5, right, in the divisor. And I'm going to check and see how many times 2x goes into 6x cubed. Remember the way we found it was this, right? So you divide 6x cubed by 2x, so you're going to say, well, 3x squared. So 3x squared will go here. And now we're multiplying 3x squared by 2x minus 5, right? And that will give us 6x cubed minus 15x squared. Subtract, and we get 0x cubed, and then negative 4x squared. So we're going to bring 18x down, so plus 18x. And next thing, we're going to check and see how many times 2x goes into negative 4x squared. I'm going to say that 4x squared divided by 2x, that's 2x, actually negative 4x squared, divided by positive 2x, that's negative 2x, so negative 2x here. Negative 2x multiplied by 2x minus 5 will give negative 4x squared plus 10x. So again, subtract 0x squared. 18 minus 10 is 8x. Bring negative 20 down. This time compare positive 2x by 8x. We're going to say 2x goes into 8x 4 times. So plus 4. Then 4 times 2x minus 5 would equal 8x minus 20. Subtract. And we get 0x plus 0. And that would be our remainder here, 0. So let's take a look at the quotient. The quotient here is 3x squared minus 2x plus 4. The quotient that we got from synthetic division is 6x squared minus 4x plus 8. And I'm going to place them next to each other because I want the comparison to be more visible. So the quotient from the long division is 3x squared minus 2x plus 4. Remainder still 0. And now I'm thinking, I got two different quotients for the same division, so one of them is right, okay, and the other one is wrong. So which one is the correct one? I would say that the long division answer is the correct answer. It works all the time for any kind of division, any kind of polynomial. But if I compare the quotient that I got from synthetic division, compare number 3 with 6, negative 2 with negative 4, 4 with 8, you probably notice that the quotients received in the synthetic division are, I should say, inflated or doubled. So 3 times 2, 6. Negative 2 times negative 4, times 2, negative 4. 4 times 2, 8. Or in other words, in order to go from the quotients that I received from synthetic division to the quotients that I got from long division, they're all divided by 2, right? So you must divide these quotients by 2 to go to the right answer. Now, why do you think this happened? Remember that when we divided here by ax minus b, we only took 5 over 2 and placed it in here for b. In other words, we wrote 2x minus 5 as 2 times x minus 5 over 2. So these two are exact same thing. But we pretended that this number 2 here didn't exist at all, so we kind of removed it from the scene in here. Sorry about that. I'm going to make this a little bit smaller. So we kind of removed that number 2, and we divided, technically, we divided the polynomial by x minus 5 over 2 instead, by placing this one here. So we divided it by a number 2 times as small, and that's what made the quotient 2 times bigger than it should have been. So when we use synthetic division, in cases when divisor is in the form ax minus b, whatever quotients we receive or we obtain at the end, they must be divided by the coefficient a, or in our case, number 2 here. So we're going to say that we must divide them all by 2 before we make a decision on what the quotient is. So the method is still valid. We can still use it, but we must keep in mind that the coefficient a will play a role at the end. And that's a surprise that I was talking about. And I hope it's not a very, not so amusing surprise, but it's just a way for us to remind ourselves of what is going to happen and how to perform the synthetic division correctly in division by ax minus b. So